Okay, I want to talk about statistical inference again. I know we talked about this before spring break, but I want to touch on this again because this is really the foundation of what's going on in this course. So we have this table, and on this side, we're asking the question, was your sample randomly selected? So we have the sample was randomly selected and the sample was not randomly selected. And the thing about randomly selected samples is it allows you to apply your results to your population. So that's why I have you can generalize your results and you can generalize your results. Down here, this row that goes across, what's not randomly selected, you cannot generalize your results in either one of those. The other piece of this is the random assignment to a treatment group. So if you do randomly assign someone to a treatment group, you do get cause and effect out of that. If you don't randomly assign people to treatment groups, you do not get cause and effect. So let's take a look at this table. So if a sample is randomly selected with a random assignment to treatment groups, this is like the holy grail. You can infer cause and effect and you can generalize your results to your population. So that's like the best of all worlds. If your sample was randomly selected, but you didn't assign people to treatment groups, or you didn't have a treatment in there, so you were doing maybe an observational study, then what happens is you can generalize your results to your population, but you do not get cause and effect. Okay, so this is that correlation relationship where we use that weaker language. Okay, this box here, the sample was not randomly selected, so maybe we had volunteers, but we did randomly assign them to treatments. So this might be like a medical trial. And in this case, we can infer cause and effect, so we'll get cause and effect on whether the drug was helpful, but we can't generalize our results to our population, and that's where we want to use that replication element. So if we can replicate this study enough times with a variety of people, maybe a variety of locations, we can get at being able to generalize our results. And this is the worst box to be in. You didn't do a random sample, you didn't randomly assign people to treatment groups, and so you're not going to get anything out of this. There's no cause and effect, you can't generalize your results. And so I guess I would ask what research you're doing or why you're doing that, because this isn't going to be very helpful for the amount of time and effort you're going to put in. So random samples, random assignment to treatment groups, those are the two things that we're really interested in when we look at statistical inference and what we can do with our results.